Good morning, students. I am happy to invite you for Bridge Course 2, Connecting Secondary Level Chemistry with Senior Secondary Level Chemistry. In the last class, we have seen what are the basic concepts of chemistry involved in ninth class chemistry chapters. Right. I told you, please take your ninth class chemistry book and revise all those basic concepts involved in the chemistry, right? So I hope many of you have done. I believe that. Very good. Keep it up. Now, what are the chapters in 10th class and what are the concepts involved in 10th class chemistry? We are going to see in detail. Grade 10 chemistry chapters. Number 1, chemical reactions and equations, acid, bases and salts, metals and non-metals, carbon and its compounds, periodic classification of elements. There are totally 5 chapters you have learnt in 10th class chemistry, right? So now we will see briefly what are the important concepts you have learnt in 10th chemistry. Okay, now we will go chapter wise one by one. Chapter 1, chemical reactions and equations. So we get product when the reactants combine, right? So definition of chemical reaction, it is the reaction between the reactants or combination of reactants to give products. What happens during chemical reaction? The old bonds are broken and new bonds are formed in the product side. In a chemical reaction, the product will have entirely different properties than the reactants, right? Example, when sodium, highly reactive metal which catches fire, react with chlorine gas, a harmful gas, it gives sodium chloride, right? So where do we use sodium chloride? Yes, you are correct. We use it in our food as table salt, right? See, the property of product sodium chloride is entirely different from the reactant we use. Then we learned how to write a chemical equation, word equation, symbol equation, right? Then you also learned how to make the chemical equation more informative using state symbols, right? Solid means S, right? Liquid L, aqueous solution AQ, gas G, formation of precipitate downward arrow, evolution of gas upward arrow, heat we use a triangle symbol, so etc. Right. Then the most important thing in chemistry is balancing of chemical equation. So I used to suggest or tell students, if you know how to balance a chemical equation, you will be balancing everything, every situation in your life, right? So this is a very important fundamental thing for all the science students to balance, to know the balancing of chemical equation, right? Then in this chapter we have also learned types of chemical reactions. Okay, combination reaction, two or more reactants combine to form single product, right? Example, magnesium ribbon burns in oxygen to form magnesium oxide, right? Then decomposition reaction, it is just opposite to that of combination reaction. Here single reactant breaks down to form two or more products. So if you want to break anything, you need to give energy. So here we supply 3 forms of energy: heat, electricity, light. If heat is supplied, it is known as thermal decomposition. Example, lead nitrate, when it is heated, it decomposes to form lead oxide, nitrogen dioxide and oxygen, right? When electricity is supplied, it is known as electrolytic decomposition. Example, electrolysis of water, electrolysis of sodium chloride, etc. When the light is used, the reaction is known as photolytic decomposition. So silver chloride decomposed to form gray silver and chlorine gas, right? Then third type of chemical reaction is single displacement reaction. Here more reactive metal displaces the less reactive metal from its salt solution. More reactive metal displaces the less reactive element from its solution. Here example given, zinc with hydrochloric acid gives zinc chloride plus hydrogen gas. Zinc with sulfuric acid gives zinc sulfate plus hydrogen gas. Now what is the test for hydrogen gas? So when we bring a burnt matchstick, it produces pop sound. Correct. Next, double displacement reaction. So here it is the mutual exchange of ions when two aqueous solutions of the compound are mixed. Sometimes this reaction leads to formation of precipitate. Example, lead nitrate plus potassium iodide gives lead iodide yellow precipitate plus potassium nitrate, right? So this reaction also sometimes known as precipitation reaction, right? So next type, oxidation and reduction reaction. Shortly we can call it as redox reaction. Oxidation is the process which involves addition of oxygen or removal of hydrogen. Reduction is the process which involves addition of hydrogen or removal of oxygen, right? Next we have learnt corrosion. So corrosion is a type of oxidation process only. Iron in presence of oxygen moisture undergoes oxidation to form iron oxide. Ferric oxide Fe2O3.XH2, a brown colored substance known as rust, right? How to prevent rusting? So you are familiar with that. Now what about rancidity? Rancidity is the oxidation of food items containing fat and oil, resulting bad smell and bad taste, right? So how to prevent rancidity? Yes, of course you know it very well. So now chapter 2, acids, bases and salts. In the early days, the chemicals were classified on the basis of taste. A substance which are sour in taste is known as acid, bitter in taste they are known as bases. But it is not always good to taste the chemical because some of the chemicals are poisonous, right? So now how to identify the given substance is acid or base? So in chemistry we use the substance known as indicators. So indicators are the chemical substances which shows different colors, characteristic colors with acid and base, right? So indicators can be natural, example litmus solution, turmeric, etc. Synthetic indicators are phenolphthalein and methyl orange, and and I hope you know the colors of these substances with acid and bases very well. Then you have learnt about olfactory indicators, so which changes smell with acid and base. And then also you have learned chemical reactions of acids and bases, how acid react with metal, how acid react with metal carbonates and bicarbonates, and when acid react with bicarbonates it releases carbon dioxide gas. Yes. So what is the test for carbon dioxide gas? So when carbon dioxide gas is passed through lime water, it turns milky, right? Then you have learnt strength of acids and bases. What do all acids have in common? So acids are the substance which contain H plus ions, right? If the substance contains more of H plus ion, it is more acidic, right? So similarly base means which contains hydroxide ions, OH negative ions. More the OH negative ions, more basic, right? So to calculate or to identify the strength of acid, so in chemistry we learn a scale known as pH scale. So pH means potency dehydrogen, which means power of H plus ion concentration. So in pH scale 1 to 7 it's acidic, 7 is exactly neutral, and 7 to 14 basic. So pH of the acid can be determined using pH paper or universal indicators. So for your clarification, you have given in the slide, so acidic substances and basic substances in our daily life. Then we have learnt about importance of pH, right? So how pH plays its important role in the soil, in our digestive system, in tooth decay, in animals warfare. This and all very familiar, and you might be knowing it thoroughly. Next, in this chapter we also learn chemicals from common salt. Formula of common salt is sodium chloride, right? So it's cheaply available. Where it is available? In the seawater or in the Himalayan rocks in the form of rock salt. So from seawater, by the process of evaporation, we get huge amount of sodium chloride. So sodium chloride is used to prepare many other chemicals industrially. All these chemicals are very useful to our daily life, right? So by the process of chlor-alkali process, it is electrolysis of aqueous sodium chloride, which gives three main products: sodium hydroxide, chlorine gas, and hydrogen gas. All these products are very important. So bleaching powder, what is its formula? CaOCl2. It is known as calcium oxychloride. When the chlorine gas obtained from chlor-alkali process passed over slaked lime, calcium hydroxide, it gives calcium oxychloride, and it acts as a disinfectant. So next product, baking soda. Baking soda is obtained when sodium chloride is treated with ammonia and carbon dioxide water. It gives sodium hydrogen carbonate. It is known as baking soda, right? So baking soda with edible acid is known as baking powder. So all these compounds, baking soda and baking powder, very essential compounds and used in our kitchen, right? What about washing soda? Na2CO3 dot 10H2O. It is obtained by the decomposition of sodium bicarbonate followed by water of crystallization. It gives washing soda, and you know the use of washing soda. So lastly, plaster of Paris, POP, plaster of Paris. So when calcium sulfate, that is gypsum, calcium sulfate, CaSO4.2H2O, when it is heated, it loses water molecule, one end of water molecule, to give calcium sulfate hemihydrate, is known as plaster of Paris, and you know the use of plaster of Paris very well. Okay, now we'll see chapter 3, metals and non-metals. If I ask you define metal, you may be saying metal hard, shiny appearance, more density, malleable, ductile. Yes, you are correct. But what is the exact actual definition of metal? So metal are the element which has tendency to lose electron, whereas non-metals are the element which has tendency to gain electron, right? So when we learn physical properties of metals and non-metals, metals are hard, malleable, ductile, sonorous. Non-metals are just opposite to that of metals, with some exceptions are there. So regarding difference between metals and non-metals, you have been learning from your 8th class, right? So now order of reactivity of metals. So order of reactivity of metals are categorized on the basis of the reaction of metals with water, hot water, steam, with acids. So on the basis of the reactivity, metals are arranged. It is known as reactivity series of metals. So in the reactivity series, hydrogen is placed. You can see here it's not a metal, it is non-metal. Why it is placed in the activity series of metal? So here we understand that the metals placed left to that of hydrogen are more reactive than hydrogen. These metals can displace hydrogen from the acids, whereas metals placed right side of the hydrogen here, they are less reactive than hydrogen. These metals cannot displace hydrogen from the acids, right. Next, another important thing in this chapter, the reaction between metals and non-metals, right. So in the beginning I told metals are the element which has tendency to lose electron, non-metals are the elements which has tendency to gain electron. For example, in the slide you can see sodium atomic number 11 with electronic configuration of 281. So it has tendency to lose one electron to attain the stable noble gas configuration, whereas chlorine atomic number 17 with electronic configuration 287. So if it gains an electron, it will become 288 noble gas argon electronic configuration. So element lose electron or gain electron to attain the stable noble gas electronic configuration. It is known as octet rule. So sodium lose electron to become sodium positive ion, chlorine gain electron to form chloride negative ion. So when the electrostatic force of attraction take place between cation and anion, the bond formed is known as ionic bond. So ionic bond is the bond formed between metals and non-metals by complete transfer of electrons, right. Extraction of metal and formation of alloy. So next topic, so regarding extraction of metal, so how do we extract metal? Metals are of three types: highly reactive metal, medium reactive metal, low reactive metal. So on the basis of reactive nature of metals, there are different methods are involved in the extraction of metal from its ore, right. So the collective process, the number of process involved in the extraction of metal from its ore is known as metallurgy, right. Now you know the definition of mineral. It is the earth crust in which metal is present along with the impurities. Ore is that mineral from which metal can be extracted economically and easily. For example, aluminium is found in fluorspar, clay, bauxite, cryolite, but industrially aluminum is extracted from only bauxite mineral. Hence, bauxite is the ore of aluminium, right. What do you mean by gangue? So gangue is the unwanted impurities present in the ore, right. So in metallurgical process, highly reactive metals are obtained by electrolytic reduction. Moderately reactive metals are obtained first by calcination, is used to convert carbonate ore to oxide ore, then reduction with suitable reducing agent. If the ore is sulphide ore, it is converted to oxide ore through roasting process, then reduced to metal using suitable reducing agent. What about low reactive metal? So these metal are obtained by just by heating. For example, cinnabar. Cinnabar is the ore of mercury, HGS, and it is heated with oxygen or roasted with oxygen. It gives mercury oxide. Further strong heating, it decomposes mercury oxide to form mercury and oxygen, right. Alloy formation. Alloy is the mixture of metal with metal or metal with non-metal. It's an example of homogeneous mixture, a solid solution. Alloys plays important role in our life as brass, bronze, steel, stainless steel, German silver, solder alloy, etc., etc. What do you mean by amalgam? So amalgam is the alloy in which metal is combined with mercury. So amalgam contains mercury along with some other metal. Now chapter 4, carbon and its compounds. So in chemistry we have three main branches: physical chemistry, inorganic chemistry and organic chemistry. Dear students, organic chemistry mainly depends upon the chemistry of only one element in the periodic table, that is carbon. Carbon atomic number 6, electronic configuration 2, 4. So valency of carbon is 4. So it is known as tetravalent element. So carbon has a unique property. It neither loses electron nor gain electron, but undergoes sharing of electron. So now it comes in your mind, sharing of electron means what is the bond formed? Yes, covalent bond. You are correct. So covalent bond is the bond formed between two atoms by mutual sharing of electron. Catenation. Catenation is the unique property of carbon, which has ability to link with itself in any number. So carbon can form bond with carbon in any number. It can be straight chain, branched or cyclic. Next, multiplicity of bond. So carbon forms single bond, double bond as well as triple bond. Right. Allotropes of carbon, it is the existence of a same element in two or more forms. Allotropes of carbon: graphite, diamond and fullerene. And you know very well, graphite being a form of carbon, a non-metal which has ability to conduct electricity, right? And diamond is the hardest substance in the nature. Next, the compounds of carbon and hydrogen are known as hydrocarbon, correct? So these hydrocarbons can be saturated and unsaturated. Saturated means here carbon atoms are connected through single bond. They are known as alkanes. General formula CnH2n plus 2. What about unsaturated hydrocarbons? Here carbon atoms are linked either through double bond or triple bond. So double bond compounds are known as alkenes, CnH2n, whereas triple bond compounds are known as alkyne. General formula CnH2n minus 2. Right. Next, you have learned isomerism. So isomerism is the phenomena of two or more compounds having same molecular formula but different physical and chemical properties. Right. So isomerisms are two types: structural isomerism and stereoisomerism. Right. So under structural, what do you mean by structural isomerism? Two or more compounds having same molecular formula but different structures. Right. So example, N-butane, isobutane; in pentane, N-pentane; isopentane, neopentane. So this and all you have learnt. Now homologous series, it is a series of a family of organic compound in which successive member differ by CH2 group, right? So example, if you take methane, ethane, propane, butane, the difference between two compounds is CH2. That is homologous series. What do you mean by functional group? It is a group which is attached to carbon chain, which largely determines the property of compound. Example, OH alcohol, CHO aldehyde, C double bond O ketone, COH carboxylic acid, etc. And more functional groups you will be learning in 11th class. Next is IUPAC nomenclature. So International Union of Pure and Applied Chemistry, a committee of scientists, they formed rules and regulations to name a compound prepared in the laboratory. So to name a compound, you have to follow certain rules. So very few rules or naming of very few compounds you have done in 10th class, but in 11th class you will be learning all the rules and regulations and all the functional groups. That will be more interesting to learn. chemical properties of carbon compounds. So under this topic we have two main compounds, ethanol and ethanoic acid. So ethanol has many advantages in our day-to-day life. So nowadays doctors advise to save from coronavirus, use sanitizers, right? So sanitizers are made of 70% ethanol and 30% isopropyl alcohol. Spirit, ethanol is used in the form of spirit, in the spirit lamp, to cause numbness before we get injection. Polish for wooden furnitures, a main ingredient of beverages and ingredient in cough syrup and tonics, etc. Ethanoic acid is also known as acetic acid. 7% of ethanoic acid is known as vinegar, used as preservatives in pickle. So what are the major organic reactions? Number one, addition reaction. It is the characteristic property of double bond or triple bond compounds. Example, vegetable oil is an unsaturated compound. When hydrogenated with hydrogen presence of nickel catalyst, we get vanaspati, that is artificial ghee or dalda. It's an example of addition reaction. Next, combustion reaction. So organic compounds are burns with oxygen to form carbon dioxide, water, and releases lot of energy. So organic compounds, methane, ethane, butane, these are used as fuel. LPG is an example of mixture of hydrocarbons. CNG, compressed natural gas, methane, it is used as fuel. So they play important role in our life. Next, substitution reaction. It is the characteristic property of saturated hydrocarbons. So here the substitution reaction take place in presence of sunlight. For example, methane, when react with chlorine in presence of sunlight, it gives chloromethane till carbon tetrachloride. That means the 4 hydrogen atoms are replaced by 4 chlorine atoms. It gives 4 products. This reaction is a very good industrial important reaction. Next, oxidation reaction. For oxidation reaction, we need oxidizing agents. Strong oxidizing agents are potassium permanganate, alkaline potassium permanganate, and acidified potassium dichromate. So this substance converts alcohol to carboxylic acid. So converting one functional groups to another functional group is an interesting thing, and it is widely used in organic chemistry, and you will be learning lot of conversions in 11th as well as in 12th classes in the organic chemistry. Chapter 5, periodic classification of elements. Elements are the pure substance made up of only one kind of atoms. Elements can be metals, non-metals, and metalloids. So how are elements classified? So from the ancient world, so scientists of different time period, they were trying to classify the elements of then known elements. History of development of periodic table. So in our textbook we see the first attempt was made by Dobriner's triad. He prepared a period of group of 3 elements, right? You must be knowing the fundamental thing of Dobriner's triad. When more elements were discovered, so his table could not have place. So next attempt was made by Newland, law of octaves. So you must know the concept of octaves in this table. Then as the number of elements were increased, again there was a problem with this table also. Then Mendeleev proposed a well structured periodic table based on the increasing atomic mass of the elements. So Mendeleev's law states that physical and chemical properties of the elements are the periodic function of their atomic mass, right? So he made a table. He had groups and periods, right? And how many groups and how many periods you must be knowing. And he was successful in explaining or classifying the elements, and also he had some limitations with this table, right? So now we have modern periodic table. It is based on increasing atomic number. Modern periodic law states that physical and chemical properties of the elements are the periodic function of their atomic number. So this table is the conclusion of the arrangement of elements in the periodic table. So this table successfully explains all the limitations of Mendeleev, and even till date it is a proven table. So no other table was discovered to overcome this modern periodic table. Features of periodic table. So this table consists of 18 vertical column known as groups and 7 horizontal periods. 7 horizontal rows are known as periods. So the elements placed in a group show similarity in properties. They are known as periodicity. Periodicity means repetition of properties of elements after certain intervals, 2, 8, 8, 18, 18, 32. They are known as magic numbers. And this table, when we talk about size of the atom of this table, when we go down a group from top to bottom, the atomic size of the atom increases because shell number increase. Whereas when we go from left to right, the atomic size decreases, right? Because shell number remains same, but the effective nuclear charge increased by 1 unit. Hence, more the attraction, less the size. Metallic character increases down the group, and non-metallic character decreases down the group. Non-metallic character increases from left to right and decreases from top to bottom. So this table consists metals, non-metals and metalloids. So students, so I thank you for patiently hearing, because all these things are needed and very important when we go to 11th class. So once again I request you, I suggest you, please go through the 9th and 10th textbook and revise all the basic concepts. That will be very useful when you start with your new 11th class. So 11th class and 12th class, you have to spend lot of time with your textbook. You have to learn so many things. You must spend lot of time with your textbooks, and concentration, dedication should be there. Then you can achieve your goal in your life. I wish you all the best for the successful senior secondary class. Thank you very much.